With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, when we write expression for energy of electron in nth orbit of hydrogen atom, we take zero potential energy at n equal to infinity. But potential energy depends on point in the reference. If we take total energy of electron in n equal to 1 orbit as 0, then match the following. So here it says, if at n equal to infinity, potential energy is taken as 0, hence total energy is given as minus of 13.6 into z square divided by, we can say as n square, and this total energy here is equal to, let's say in terms of expression of, let's say minus of kze square divided by 2r. Potential energy we have here as minus of kze square divided by r, and kinetic energy we have here as, let's say kze square divided by, we can say as 2r. Now we can see here this potential energy at infinite is taken to be 0, then this, let's say total energy comes as minus 13.6 z square by n square. Now it says, if at n equal to 1 orbit, we take the potential energy part to be 0. So the negative of potential energy of electron in n equal to 1 is being asked. Hence we can say at n equal to 1, let's say if reference is, let's say at n equal to 1, hence we can say here at n equal to 1 we need to take reference as 0, that is total, let's say energy of the electron in n equal to 1 orbit as 0. So we can say here its potential energy and kinetic energy and total energy at n equal to 1 orbit is taken to be 0. Now we can say here its potential energy and kinetic energy will be equal in magnitude. Initially we can say here, if reference was not taken, so we have initial total energy at n equal to 1 orbit for hydrogen as minus of 13.6, and we have the expression here as total mechanical energy E, let's say is equal to, we have here as U divided by 2, and we can say here E is equal to, let's say K is equal to, we can say as minus of E. So we can see here that, let's say potential energy, let's say will be 2 times E, that is minus of, we have here as 27.2, and we can say here kinetic energy is equal to plus 13.6. So here if we make the reference of total mechanical energy as 0, kinetic energy will still remain to be our, let's say 13.6. So kinetic energy will still remain to be 13.6, but potential energy, now here if we add this 13.6 here, so we can see here this, let's say potential energy will be also added as 13.6, hence we can see here this comes as our, let's say here as minus of 13.6. So the first option says negative of potential energy of electron in n equal to 1. Here we can see this potential energy negative value will be 13.6 eV. Hence option A matches with, let's say P, as well as here we can say it depends on the reference level also. If we take the reference level at n equal to, let's say 2, we have, let's say total mechanical energy as, let's say 2.54 minus 2.54. So in that case we will add 2.54, so it will depend upon which reference level is being asked. Hence A matches with P and R. Now coming to option number B. B says ionization energy from the ground state. Hence ionization energy from the ground state here can be said as, let's say here we can say the ionization energy from the ground state is, let's say at infinity the total mechanical energy was 0. Now if we add here, let's say 13.6, now we will add 13.6 to each level. So the ionization energy will be the energy required to ionize the electron from the ground state to n equal to infinity, which here comes to be our, let's say 13.6. So here we can say here B matches with our, let's say P, as well as we can say here it does not depend on the reference level. Now whether we take from n equal to 2 to n equal to infinity, since we add here in this reference level for n equal to 1, we add 13.6 in the starting and 13.6 in the infinity also. So the difference still remains to be the same. So it does not depend upon the reference level. Hence we can say here option number P and S. So coming to option number 3, total energy of electron in n equal to 2. Now we know here in n equal to 2 orbit we have total energy as minus 3.4 electron volt when reference was at infinity, that is 0. Now if we take reference as n equal to 1, so this 13.6 adds here. So 13.6 minus 3.4 becomes our 10.2 electron volt. Hence we can say here C matches with our Q, and we can say here it depends on the reference level. Since here we have taken n equal to 1 as the reference level, so we can say here we add 13.6 here. If we had taken reference level at, let's say n equal to 2, in that case we would have, let's say, added 3.4. So in that case the total energy would have been 0. So we can say here it depends upon the reference level. So option number we can say as R. Now coming to D here, D part, it says excitation energy for n equal to 1 to n equal to 2. So here in this case we can see here when, let's say, reference level was at infinity, this excitation energy for n equal to 1 to n equal to infinity had, let's say, value of 10.2 electron volt. Now here also when the, let's say here reference level is n equal to 1, in this case also we have the excitation energy as, let's say, final minus initial, as we have here as 10.2 electron volt. So in this case also we can see here the excitation energy in both parts come to be Q, and it does not depend upon reference level. Hence we can say as S. So here is the correct matching, that is A matching with PR, B matching with PS, C with QR, and D with QS. Hence this is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.